Hi, I'm Mark Mullins, and I'm joined here today by Michelle Mendoza. Before joining us at Fluke Networks, Michelle, you were the supervisor at an air separation plant.
That's right, Mark. And while I was there, one of the critical aspects of keeping our plant running was our industrial automation control system. These systems run on industrial Ethernet and are becoming the most common way of controlling complex manufacturing processes. But in these harsh environments with electrical noise, moisture, temperature extremes, and vibration, the cabling can become a point of failure.
Well, exactly, and research has shown that more than half of the industrial Ethernet failures are the result of cabling problems.
Wow. As a supervisor, one of my top goals was to prevent plant upsets. So how can I make sure that cabling problems don't lead to plant upsets and downtime?
Well, that's where cable testers like this one come in. They check the cabling to ensure that it's been connected properly.
I can see how that would make startup easier, but how about preventing problems?
Well, they also measure a number of electrical parameters that can help you predict and prevent future issues. Industrial Ethernet is designed to run well, even in the face of problems. But if they get too great, like a little too high temperature, a little too much moisture, a little too much vibration, suddenly the whole thing can shut down.
And then how does the tester work?
Well, the tool makes more than a dozen different physical measurements, but the result is a simple pass or fail. And then if you do have a failure, it'll have simple diagnostics to help you pinpoint the problem and get back up and running fast.
Thanks, Mark. To learn more, visit our website, flukenetworks.com/industrial, and look out for our next video with more on industrial Ethernet troubleshooting.
Good afternoon, everybody. My name is Zuili Eklare, and I'm from Publish Industry India Private Limited. Publish Industry India is a 100% subsidiary of Publish Industry Verlag GmbH Germany that publishes the trade magazines A&D India, which is Automation and Digitization, and EM, which is Efficient Manufacturing. I will be your host for today's webinar, and it gives me great pleasure to welcome all of you in association with Fluke Networks to the webinar on the importance of cable testing in industrial automation systems. The rising prevalence of Ethernet on the plant floor has been obvious for a long time now, but the increase in remote working because of the pandemic has only led to the emphasizing the significance of Ethernet in the industry. What's more, industrial environments expose Ethernet connections and cabling to mechanical shock, contaminants, electromagnetic noise, etc. However, it may come as a surprise that the cause of most industrial Ethernet downtime is cabling, and this is especially true in industrial and manufacturing environments. Therefore, operational technology experts need to simultaneously troubleshoot and enhance infrastructure, plan for future boosts, and endeavor to grow the network in the direction of higher speeds. Cable testing must be done so that one can decide the power system's condition, spot cable failures, and recover system reliability. Today's webinar on the importance of cable testing in industrial automation systems will throw light on how this problem of downtime due to cables can be solved, the most common methods for cable testing, and more. So before we begin today's webinar, I would like to inform all of you that at the end of the presentation by Mr. Koo, we'll be open to Q&As. And if you look at the bottom of your screen, there's a Q&A icon. So just put your questions in there and we will have them answered. So let us begin by welcoming Mr. Roger Koo, Fluke Networks APAC Technical Support, to talk on the importance of cable testing in industrial automation systems. Mr. Roger, over to you.
Thank you, Julie. Can you hear me well?
Yes, we can hear you.
Oh, good. Okay, I hope you can see me as well.
Yes, we can see you. We can see you. Okay.
Now, good afternoon, everyone. The goal of today's topic is to understand the importance of network connectivity in your industrial automation system. Through this presentation, we hope you can gain valuable information to increase your productivity. If you have experienced frustrating intermittent system or connectivity issues, which took away precious time and resources to find the cause, then this is the presentation that you should attend. Let's start with a look at the trends in industrial automation installations. According to a recent market survey, 65% of the new IA installations employ some form of industrial Ethernet and is growing rapidly. Within this group, Modbus TCP was one of the first industrial Ethernet introduced, but Profinet and Ethernet/IP are the most popular ones today. Fieldbus technologies are still growing, are still showing a decline, over the previous years, but the decline is stabilizing. In APAC, Profinet and Ethernet/IP are still the most popular technologies being installed, followed by Profibus deployment, and the market is still fragmented. Interestingly, wireless is again showing growth, and it is something that we should all look out for. In another report on the adoption of industrial Ethernet, despite COVID-19 crisis, IE is estimated at US 35.4 billion in the year 2020 and projected to reach USD 97.8 billion by 2027. That's a compounded growth rate of about 15.6% over this period. Now, the adoption of IE has been increasing so rapidly. There must be some valid reasons for that. IE is seen as a universal solution across the whole manufacturing operation environment. No longer are the production and the office network seen as separate operations. Ethernet, first officially published by IEEE 802.3 in 1983, has been around for more than 40 years. It's a mature technology. Compared to other protocols, Ethernet is more deterministic, supports higher bandwidth, and is simple to maintain, all attributes that industrial Ethernet requires. Now, before I start with this slide, I would like to pass it over to the moderator for a quick poll.
Can we please have the poll on screen? Yes. Do you know 50% downtime in industrial automation plants is due to physical media cabling issues? Your options are yes, no. You have 10 seconds to vote. Please go ahead and vote. Can we conclude the poll? Yes, so 71% have said yes, and 29% have said no. So thank you for voting, audience. Mr. Koo, back to you.
Yeah, I guess I did not share the screen just now. I apologize for that. So I hope you can see the screens that I am showing.
Yes, we can see the screen.
Okay, thank you. So thanks for the poll. It looks like almost half-half, but it's good. It's good information. So let me carry on with my presentation. Now, the backbone where Ethernet runs on is the cabling infrastructure. Now, understanding how to maintain and care for the physical layer is of vital importance to the overall productivity of the operation network. According to different data sources, over 50% of industrial Ethernet problems comes from the physical layer. Cables and connectors form this layer and can be pre or field terminated. Pre-terminated cables are designed and configured beforehand, manufacturers tested, and delivered to the site for installation. Issues could arise from wrong cable for the application, re-termination at the site as the slack could be too long, or damaged cables during transit or installation. Field terminated cables, in addition to the issues mentioned, could also be subjected to wrong wiring, untwisting too far into the cable, resulting in higher noise or a loss of shielding integrity. Industrial environment demands higher level of design and workmanship as the environment makes everything worse. This could result in more intermittent problems that are difficult and time-consuming to diagnose. Can I just check, are you able to see my slides? I think there are some messages that my slides are not showing it.
We can see the slides. I mean, we can see the current one. Cabling is over 50% of industrial Ethernet problems. We can see that one.
Okay, okay. Then those must be older slides. Okay, so let me just go on.
Yes, we can see this one.
Okay, from an architecture perspective, operational technology is a lot like the information technology. Both have end devices that communicates through a fabric of switches and gateways. OT in industrial automation is a category of computing and communication systems to manage, monitor, and control the industrial operations, with a focus on the physical devices like the PLCs or the VFDs, and the processors that they use. So in short, it mainly interacts between machines. IT deal with mainly computers, telecommunication systems for performing various input or output operations, for storing, transmitting, manipulating, as well as converting the data to information so that it can be exchanged among different organizations. It deals with information rather than machines. But you must have heard of IT and OT conversions, and sharing that same physical layer is a major step in the direction. In the IT world, Ethernet has grown to become the world's most common networking system. In OT, vendors and standards organizations have adopted the underlying physical layer of Ethernet to create a variety of technologies, such as Ethernet IP, Profinet, EtherCAT, CC-Link IE, Modbus TCP, just to name a few. All these protocols are optimized for industrial automation, sharing that same physical layer. They use the same types of cables, category 5E, Cat6 or Cat6A, albeit with additional jacketing to protect from the harsh environment. Same connectors, RJ45, often industrialized version of it. There could also be specialized connectors like the M8 or the M12. There are some fibers as well, again with additional jacketing. Good networks have a range of products that work on the physical layer for both the OT and the IT. Like the IT network, testing the install for industrial network is necessary, more often required. Changes in production line, movement of resources and machineries, switches, routers, PLCs. When we are planning out new industrial Ethernet network, we tend to ignore the cabling, assuming that everything will work out fine. We forget that unless our cabling infrastructure is good, these technologies and applications will not work correctly. The data cabling is the foundation of our network. If you do not get it right and you do not test it correctly, you could be headed for serious issues that can be hard to correct once the network is in service. All stakeholders involved needs to ensure the operations are not disrupted and the project running costs are maintained at an acceptable level. Without proper testing, you may face with longer startup time. Things may not work right off after assembly, and time will be wasted getting it to run due to a cabling issue. Move, adds, and changes are typical in a production line, and any of such activities prior to verifying the cabling structure will cause the whole line to go down. Not forgetting moisture, vibration, contaminations, and EMI. An outage can cost more than testing correctly in the first place. Well, this is an example of a utility vehicle manufacturer that's based in the United States that we have worked with. Every hour, 6 trucks can roll off their production line. That is equivalent to about $240,000 an hour. When they face an issue, what is typically done is they will install a bypass cable, and that itself takes an hour. Now, the installation of this bypass cable is to save them time so that they can verify that it is not the physical layer that is causing the issue. But guess what? It's $240,000 down the drain. What if they have a tester? A tester only takes them 10 minutes to verify that the physical link is good. If that is good, then they can move on to test the end devices. That actually saves them 50 minutes, which is about $200,000. That's the figure that's given by us, given to us by them. Now, for this manufacturer, correct testing paid for itself just within a few minutes. If you are a beer or a milk manufacturer, think of the savings that you will get just from investing in a good cable tester. Standards organizations recognize a need to address the harsh environment that can cause intermittent network problems by creating the TIA 1105-A standard and the ISO 11801-3 standards. They both refer to MICE, where M stands for mechanical, which is flex and vibration, I for ingress, talking about moisture, C is climatic, or temperature, and E is electromagnetic, noise, in a layman's term. Each of these attributes are assigned a rating to indicate the severity of the environmental conditions, 1 for low and 3 for high. My standards apply to cabling products supporting all industrial Ethernet protocols. So now the question is, when do you test the cables? Silk Networks tools can be used to validate and verify industrial Ethernet cables to avoid the startup delays. During assembly, cables can be checked if they are terminated properly with the correct configuration, shielding, and the conformance to the MICE ratings. During installations, verify the cables are not stray or broken. Validate that the signal loss of the link are within the acceptable limits. Then the next question would be, where should the validation and verification take place? Or at the machine builder or the OEM? Our purpose is to catch the problem before the machine was disassembled and shipped to the customer. Test again at the destination plant when delivered and reassembled to ensure nothing is broken or changed. Lastly, do always remember to document all cable test results with complete details of all measurements for verification and traceability. What can you do if the cables fail? Well, due to handling and various environmental factors, cables do fail over time. So what is important is to be able to minimize the downtime, identify the cause in the shortest possible way, and rectify it. A complete cable test end-to-end takes less than a minute. If it is good, great, you have eradicated the physical layer as a possible cause. Move on to find for other possible fault sources. If it is bad, well, you know what to do. So here is a link that we can look at what we will test. You see that this cable is actually connected to both ends of devices. This is a typical Ethernet link. What is shown here is a cable, is a 4-paired cable. which are connected to the ends of our RJ45 plug. It may be terminated into a jack. The M8 or the M12D, which is 2 pair cables, connectors are being shown here. The M12X 4-pair connector is the one shown in this picture. Now within this link, there could be an initiation point for patching. So that's what is added. And at the end of it, there could be optional zone enclosure where media converters usually resides. So in this picture, you see an adapter that converts the M12 to the RJ45 connector. Now, miswiring is the biggest source of issues in data cabling. The simplest of problems can lead to large issues in any IE network. You can see from this diagram to the right that we have placed our terminator at the far end. Let me just highlight it, which is right here. It is terminating the M12 X-cut connector. The IE kits that we have provide the terminator and the appropriate test interface cables. The link IQ is connected to the link at the near end using an RJ45 to M12 patch port. We have a full set of cable adapters available to facilitate the testing of commonly used industrial Ethernet connectors. Here we can see that the link IQ is indicating pair 1 and 2 shorted at 4.5 meters away from itself. If you look at the diagram top right of this link, we would have to suspect that this M12 connection closest to the tester is the likely culprit for the failure. So if you tap the pairs and we get into a deeper look, this confirms that the problem is that first cabling segment. You can see that the other 3 pairs all go up to the far end termination. Now, this is a common problem. One end of the link has been wired to a T568A wiring code, and the other end has been wired to the T568B wiring code. You can also see this failure if you have accidentally installed a crossover cable, where a straight-through cable should have been used. Now, in this example, we see a failure caused by a split pair. Unfortunately, low-cost continuity testers usually miss this problem. This issue is common where inexperienced technicians are terminating the cables in clear plastic cream-style plugs. If you forget pair 3.6 is split across pair 4.5 and directly terminate the pairs into the plug, this is the result you will see. DC continuity is perfect. As you can see, pin 3 actually goes to pin 3, pin 6 to 6, 4 to 4, and 5 to 5. However, from an RF point of view, this mistake will cause a large signal to noise ratio, which is an issue within the link. Too much noise will corrupt Ethernet packets, stopping the connected devices from working correctly. Another common problem we see is the pair reversal. Now in this case, pair 4.5 has been reversed at the ends. The LinkWare IQ has identified this issue and the LinkWare IQ was set up to test the cables to 2.5 gigabits per second transmission rates. Now, because of this pair issue, the tester has failed. The link at all 4 pairs are not working correctly. However, the 10 meg and the 100 megabits per second will still work, as they only rely on pairs 1, 2, and 3, 6 to work properly. as you can see in the meters here, the green portion and the red portion. Here we have a perfect link. Everything is working, and the link can support a transmission rate of up to 10 gigabits per second. In the previous slides, we could have saved all those tests to the tester to document what we have found. Using Linkware PC software, which is a free product from Fluke Networks, you can upload your test results and print out the testing report to show that the cable and the switch ports were working correctly. Here's another case study shared by another customer. It is a wind farm located at the edge of the California desert. Now, the network fault code was continuously reported by the PLC over a period of time, and sometimes intermittently. So the machine reacted by shutting down and causing loss of productivity. Field technicians were called many times. They went to look at and do a test with their testers, but however, they are unable to identify the root cause. Now, with our tester, we are able to identify that it's a split pair. As we have mentioned previously, a split pair is not easy to be identified by a simple continuity tester. So that is something that you should watch out for. Wire map testing is insufficient to determine if the cable supports reliable communication, as what we have just shown previously. I would like to briefly introduce some of the other parameters that the tester checks, such as this first one, insertion loss. Now, what is insertion loss? Basically, you send a signal, a very low voltage signal, a 1 volt, and it's supposed to go to a distance of about 100 meters. So at the end of this cable, you are supposed to determine how much of this power do I still receive. So that's called an insertion loss. How fast will this signal go across all the frequencies that we tested? Is there noise in this cable? So if you look at the wiring here, we are actually looking at a signal transmitted on one pair and see how much is being received over at the destination. So that's insertion loss. The next parameter that we are looking at is return loss. Well, by the word itself, return loss. So on the same wired pair, how much of the signals are coming back to itself as noise? So if you look at the diagram that you see here, the tester actually shows a limit line that is denoted by the red line, a smooth red line at the bottom. And you see a number of wavy lines at the top. Now, the wavy line actually represents each of these twisted pair responses on return loss. The greater the distance between the limit line and the wavy lines will denote how good is this cable at rejecting all these return signals. As you can see in these two pictures, the wavy line actually touches and crosses the limit line. So that means that this cable failed the return loss testing. And the result of this, or the cause of this, could be badly made cable, or there could be water in the cable itself. The next parameter that we can talk about is near-end crosstalk. In fact, I think almost every one of you have experienced this before. Now, if you have a phone, imagine those olden days where we have phones, especially analog phones. Sometimes when you dial a number, you could hear other parties speaking in that line, which is not what it's intended for. But that's crosstalk. So what does that mean? That means that when signals is traveling down one wired pair, it actually crosses over to another wired pair. Thus, you hear interruptions. So this is known as the near end crosstalk because it happens at the near end. Now for the tester, it tests the near end crosstalk ratios and denote it in a diagram so that it's easy to understand. Now from this diagram, you can see spikes, which is normally happening at the connections or the connectors. And in this case, you can see along the cable, there are also multiple spikes. That will represent that this cable could be bad. Now this is going to be the last parameter, which is gaining prominence. Well, it is gaining the prevalence because of power over Ethernet. So this parameter is known as the DC loop resistance. There are associated parameters like the resistance unbalance. So basically, what is this? Anything that travels down the line, they are bound to have resistance. So the tester will measure the resistance value of a twisted pair, between the twisted pair as well. So we take all this information to try to understand, does this cable, is it suitable for a PoE use? Now, what is the impact of this then? In fact, again, this is something that every one of us has experienced before. Usually you will hear people saying, oh, the network is very slow. Why is it so slow? Well, there is a reason for that. So one of the causes could be multiple retransmissions of the data packets. Now, in this case, you can see something called the FCS, which is frame check sequence. So data travels down a wire in frames. Every frame itself, there is a check. So when it travels down the wire, at the end of it, they will do a check to see if whatever has been transmitted is exactly the same as what has been received. That's called the frame check sequence. If it's not the same, then there will be a retransmission. And if this happens too frequently, guess what will happen? Network will be slow. And it's slow, it could be because of the DC loop resistance or the resistance unbalance between the pair. So this is one parameter. If you're running PoE, watch out for that. With the link IQ, we can also perform connectivity and PoE checks. Now in this model, we connect the link IQ to the switch port or to the link termination as shown here. This will enable the evaluation of the switch port and the VLAN identification and PoE capabilities. Now it's very easy, you don't need to do much configuration. Basically plug it in and tap on auto test. With auto test, linkware will determine what it is connected to. Now once the test is completed, we can review the results on the link IQ. Here, we can see that on the switch, we are connected to port 1/0/3 at 1 gigabit per second. We are connected to a switch called switchy MAC switchy. Let me just blow this up so you can see it clearer. And it has also identified that this is connected to a VLAN called the V-access LAN. The highest capability of this switch is 1 gigabit per second, but it can also support 100 meg and 10 megabits per second at full and half duplex. Now this switch is also capable of offering power on all 4 pairs. With hardware negotiation, the switch is capable of offering up to class 4 PoE power, which is 25.5 watts. Under software negotiation, the switch is capable of offering a little more power, class 5, which is 30 watts. This tells us that most likely this switch is a newer IEEE 802.3 BT PoE capable switch. Now, showing the advertised power level by the switch is insufficient. LinkIQ applied the appropriate load testing to verify that the switch could deliver the power it is advertising. The switch may be capable of even more power, but at this point of time, it only has reserves to supply up to 30 watts PoE from this port. All the tests that we carry out on the switchboard can also be conducted at the other end of the link. This enables you to eliminate the cabling as a source of connectivity or PoE issues. Now, what about fiber? The number one issue of fiber is dust. A speck of dust is like a big boulder to the fiber optics. Now, 80% of the fiber optic problems is contamination. So always inspect and clean as the first step that you should take. Now, when I was speaking to a customer, he was asking me, is there any issue with a brand new bag of fiber optics just received from the manufacturer? Well, guess what? If you don't inspect, you will never be able to find that this is how dirty it is. Right? So always inspect, look at the end surface with a scope, even if it's brand new out of a bag. After cleaning with a test pen, if it is still dirty, clean again until you receive something like this. So this should be a clean fiber end before you insert into any connections. Now, besides the fiber inspection, there is also the OTDR. Now, what does OTDR stand for? The Optical Time Domain Reflectometer. Now, the purpose of a OTDR is to identify where the fault lies. Is it because of a poor connection, or is it because there's a break at a fiber? So this OTDR should be showing you a trace like this. You can see a number of information stated in this particular trace. Let me just briefly bring you to some of this. Any spike that you see, actually from the beginning where you see is A, this is where the OTDR starts to go through the output port, and you see a launch cord, which is a patch cord, before it engages the first connection. And thereafter, you see a fusion splice, not a fusion splice, you see two connectors very close together. These two connectors, if the OTDR is not sensitive enough, they will consolidate these two connectors as one. So again, do watch out if the OTDR is able to see two separate connectors which are very close together. The next event, which is at B, is actually a drop in the signals. And that's because two fibers are spliced together, something that we call a fusion splice. And thereafter, you see a different connection, a different spike at event E. This is due to a different type of connector, which is what we call a UPC connector at that site. And going down to event F, you see a gainer. Well, it is unusual to see a gainer. So what does the gainer mean? Means from one side, you see that this level is lower, and over at the output, it's actually higher. That's what we call a gainer. Well, that could be because fiber of different sizes are being spliced together. So you see something of a fiber mismatch over at that event F. And then after that, you see at the end of the fiber where you have the big spike and it drops down to the bottom. Let's zoom into the UPC connector. So you see this drop in the light. So how do we read this reading? The difference between this drop is actually the loss. Now in fiber, it's a little bit different from copper because fiber is light. So if you transmit light down, there will be some loss at the end. How much is that loss? So this is what we are looking at. The height of the pulse will show how dirty this connection is. The higher it is, the dirtier it is for this connector. Let's look at another use case from a customer. This is actually a mining company somewhere out very far away. They had a bad fiber on a 2-mile cable run that causes a loss of communication between the mining facility and the processing areas. Every hour, they actually incur $100,000 of downtime costs. Basically, after using an OTDR, they discovered that it is due to sand that is in the fiber itself. Now imagine in this installation, they only have 14 fibers and they bought an OTDR. You may say that, well, why do you need a OTDR for 14 fibers? Well, it's not really the case because, like I mentioned, it's a remote location. It takes a third-party technician 3 to 4 days just to come to the site to find out what is the cause. So there is this distance that we talk about. There is this resources that we talk about. So investing in the right tools would enable them to find the fault there and then. And then no extra or external technicians would be required to do this. So investing in a tool actually covers the cost just within a few faults. If you'd like to find out more, Truth Networks has a dedicated website on Industrial Ethernet. Do subscribe with us and stay up to date. And what is at that site? This is where you can see Industrial Ethernet cabling information, like the cabling standards. There are also white paper that talks about the standards and the testing requirements, videos, knowledge-based articles, as well as configurations on how to test a fiber or a copper connectivity. There is also tech support team that is 24/7 if you have Go support. So to conclude, the cabling in the industrial plant is the foundation of your control network. Build a robust foundation, use good quality components, and make sure that you test, validate, and verify before connecting them out. Wire mapping is just not good enough. It will hide issues, and that will cost you time. Over 50% of the industrial Ethernet issues are related to cabling. It certainly makes good sense to remove the cabling from the equation as the first step for troubleshooting. Eliminating the cable makes troubleshooting outrageous. To me, it's always that first step that everyone is asking. Take advice if you are not sure. There are a number of good vendors out there. They have good guides, good advisors. Do always consult them. Truth Networks is one of this party. We are also considered one of the world leaders in cable testing. We have been in this business for more than 30, 40 years. I guess that's all the time I have for today, and I will open up for questions.
Thank you, Mr. Ko, for that very engaging presentation. We do have a couple of questions for you, actually. Sheshadri A wants to know that in a continuous process industry, is there any predictive analytics for breakdown assessment?
Wow, predictive assessment for breakdown assessment. That is a very good question. So from a fluke network's point of view, we do have what we call a linkware software that allows you to see reports. We do have also a high-level report that consolidates and lets you see the patterns. But in terms of predicting when will be the next fault, that is not actually in our scope.
Okay. Okay. Another question we have is from Kanan Nadar. He is asking that is it possible to check CAN open network through any meters or through any other medium?
Is it possible to check CAN open network through any meters or through any other medium?
Yeah.
Is that the question? Okay. Sachin, I'd just like to introduce Sachin. Are you in the call?
Yeah, hi.
Yes. Okay. Are you available to answer these questions on CAN open network?
I am not that familiar with CAN open network, to be very frank.
Okay. Okay. Why don't we do it this way? Let me take this question and I'll come back to you.
Or maybe we can take it offline. We can take it offline.
Yeah, sure.
All right. All right. Moving on to the next question. Manju Natha wants to know, is there any frequency to change the Ethernet cable? And if yes, then when?
Is there any frequency to change the Ethernet cable?
Yes.
Well, okay. Now, an Ethernet cable is usually placed there for life, right? If you talk to the different vendors, they do give you guarantee or warranty for 20 years or more.
Okay.
So Ethernet cable is always there, especially those that deals with the backbone. So the question is, do you do periodic maintenance and testing to verify that it is still in good shape? Right. The backbones are permanent cables, so you typically do not move them around. So that is typically fine. But patch cords are the ones that are frequently moved around. So periodic testing is always good, especially when new standards come up. It is also good to recertify against the new standards.
Okay. Okay. Then Kanan Nadar, again, he has the question that he is saying, Kanan is saying that we have Ethernet ring network in our automation system and network is working fine, but through your meter, is it possible to check the health of the network?
Wow, okay.
Do you want me to repeat the question?
No, this question is fine.
Okay.
My line here is a bit noisy, so
okay.
Sometimes I can't hear clearly. So you do have a ring network and you wanted to check the health of this ring network.
Yes, yes.
Yeah. Now, bear in mind that a ring network, if you want to do any testing, you will have to break the network, right? So that may cause some downtime to your network. Now, in terms of testing a ring network, typically when you insert a tester, example for token ring, you would be able to see some responses. A token ring basically runs on coaxial cable, right? So the coaxial, we are only testing the physical coaxial cable integrity. We are not testing the token ring protocols. So those are two different layers of testing that we need to break out first. Token ring as a coaxial cable, typically you don't need to test it over a period of time because it is very robust. So for a ring network, I have not seen a lot of people testing it, maybe because it's very few nowadays.
Okay, okay. Then Amane has a question that does Fluke have tools for power cables?
Tools for power cables. What kind of power cables is he referring to?
That's not very clear here.
Okay, so
yeah.
Yeah, because for Fluke networks, what we do is we do test data cables that also run power, right? As an example, like the PoE cables, right? So those are low wattage or low voltage cables. Now, if he's talking about higher voltage cables, then that will be our counter or sister company, which is Fluke. Right. So Fluke will have the testers for power cables. Fluke Networks will have the testers for data cables that run low power. I hope
Just
that
to add
answered
up,
the question.
Roger, just to add up here, few
Sure.
things. Reference to power cables, if they are only looking at a two core 5 copper cables or something, basic testing on a low voltage system, not a high grade cables. We have basically testers which can help them to find out length, connectivity break, open short kind of a thing. That can be done with our TS90, TS100 kind of a product range. But if it is anything related to anything LT or ST cables, then they have to go with Fluke Industrial Solutions. Okay.
Right.
I am coming back on that can open thing.
Yeah.
Can open just to here can open mostly uses Ethernet cables only, which could be M12 interfaces or RJ45 interfaces. So we may not be able to check protocols on that, but we can check physical media, and we can assure you that physical media is working fine or not. Same in Ethernet ring. When you're using Ethernet, you will be again using some kind of Ethernet cables. We can help you to test Ethernet cable health, and we can give you with our cable analyzer how is the performance the Ethernet cables are giving, whether it is M12 interface, whether it is RJ45 interface. We can test both the things, or M8 interface. But the issue here is we will only check the physical media. If physical media is working fine, it will give you a performance report as per standard. And if it meets the standard requirements, this cable is good with physical application.
Thanks, Sachin.
Right.
Okay. Can I move on to the next question?
Yes, please.
Yeah. Pulkit Sharma is asking, are there any meters for testing MQTT protocol?
MQTT protocol. No, for us, Fluke Networks, we do not test MQTT protocol. We are not a protocol analyzer. So you may have to refer to Schneider if you talk about MQTT protocol.
Okay. Okay. Manjunatha again has a question. She's asking, how should one select the Ethernet cable?
How should one select the Ethernet cable? Wow. Well, it all depends on what you want to run on the cable. For example, in my house, I do have a network in my house. Right? I do run a network cable. And when I think 5 years, 10 years down the road, I'll still be staying in this house. So I want a cable that allows me to run higher bandwidth so that probably I can have 4 or 5 members of my house can instantaneously use that same network. Which is why when we talk about cabling standards, there are different categories like Cat 5e, Cat 6, and Cat 6a. And each of them allows you to run at different data rates. A Cat 6a cable allows you to run up to 10 gigabit Ethernet. And that is most of what we see in the market today being deployed. So 10 gigabit Ethernet may be too much for home, right? So probably 100 meg or a 1 gig network is good enough for a home environment. So it very much depends on the applications. Then you can select what kind of cable you need.
Okay, okay. Chetan Patil has a question. He's asking, is there any desktop-based application to check the cables without Fluke tester?
I'm sorry, can you repeat the question again?
The question is there any desktop-based application to check the cables without Fluke tester?
Ah, okay. Wow, good initiative. Having just a desktop software without a hardware to test a cable. Well, unfortunately, the answer is no.
No.
Right? Testing a cable is what we call a disruptive test. Why? Because we are sending signals and frequencies down a line. We are also sending voltages down a line. So that will disrupt the signals. And there needs to be specialized hardware that is able to generate these test signals over a wide range of frequencies. So the electronics in your hardware, whichever software or desktop that you have, is not able to support that kind of testing regime that the standards wanted to. So even for testers, there are different standards for a tester to conform to before you can test a link. Right. So these are all the things that are required in order for a tester to be able to certify any link. So the short answer to yours is no, there isn't any software that allows you to test the integrity of a link.
Okay. Manjunatha again has a question. She's asking, can we install the Ethernet cable along with power cable of 440 volts?
Of 440 volts.
Yeah.
440 volts.
Yeah, 440 volts.
Wow. Okay, that's pretty high powered for us. I may have to refer you to the industrial part of our sister company, which is the industrial part. We do not have an offering that allows you to test that power. Sachin, you may want to add something.
Roger, here I think the question is, can they run Ethernet cables with the power cables? It is not recommended to run Ethernet cables with the power cables of 440 volts, especially such a high voltage, which may have higher EMF and other things, which may disrupt the data things. So there are multiple guidelines you need to follow when we are using Ethernet cables. There are, how do you lay the cable? How do you jump the cable? It has to be 90 degrees and the way, and especially if you have a, these are high HT cables, then you should actually use kind of shielded solution if you are even on industrial plants kind of thing. Roger, I think now you can answer it better way because you have been in more a cabling background.
Oh, I'm sorry, I misinterpreted the question. So basically you're saying that a power cable and a data cable running side by side.
Yeah.
Okay, now, like what you have rightly pointed out, there are guidelines in terms of how far you should place a power cable and a data cable together. So if they are on the same tray, then the question is, what kind of, what quality of cables do you have? What kind of jacketing you have? All this needs to be conformed to certain guidelines. So it's not a straight answer as no. It all depends on, like you mentioned, 440 watts power cable. Maybe the separation between the data cable and the power cable will be 2 trays, right? Instead of on the same tray itself. That we have to refer to the standard guidelines for more information.
All right. Amane has a question again. Is there a tool which will detect short or open cable for 24 volts or 230 volts?
Okay, good question. Now, testing a short or a miswiring doesn't really require to talk about the voltage because a short is a short. Even an ohmmeter, a continuity tester, will allow you to test whether it's shorted. So for fluid network tester, you would be able to plug in and detect the wiring information. So what we need to know is also the connector. What kind of connectors do you have? All right. If those connectors are what we have, like the M8, M12, or RJ45, then that will be fine to test the continuity of the wire.
Okay. Anil Birania has a question. He's asking, is there any software for Profinet or Ethernet cable planning at design stage for effective data communication?
Well, I guess I will not be able to answer that question in terms of software planning because that is not in the scope of what we are managing here.
Okay.
Sorry about that.
No, that's okay. All right. So those are the questions, Mr. Koo, from our audience. So thank you so much.
Oh, thank you. Thank you everyone for spending time with us. I hope you have learned something valuable in this session. So before I drop off, I'd like to wish everyone safe and healthy for the weeks and months ahead.
Yeah, your presentation was actually it was very insightful, very valuable, very informative. We also had a lot of questions from the audience, very good questions also, and also the audience showed an interest in whatever you presented to us. So I'm sure we have a lot to learn from this. So I would like to close now. So thank you so much, Mr. Koo. So ladies and gentlemen, we'll now be coming to the close of our webinar. Before we close, I would like to thank our wonderful audience for being a part of today's webinar. I would also like to thank Mr. Koo and Ms. Sangeeta Pawar, the Field Marketing Manager at APAC at Fluke Networks. So thank you all very much, and we will see you next time.
Thank you.
Thank you.